We're going to begin with oral presentation 31, Ector County, Texas, Team 2. It's a Mission 12 flight experiment. And
Good afternoon, everyone. My name is Deidre Morales, and today I'm going to be speaking to you all about the efficacy of IDNL sequences in a microgravity environment. And I am from Ector County ISD, and I attend Falcon Early College High School. So to begin, IDNL sequences is a relatively new bacteria. It was only discovered in 2016, and as of now, there's not much research regarding it. And this bacteria is special in that it can break down and metabolize PET, which is a plastic that we use in products such as water bottles and shampoo bottles and that sort of thing. And how does IDNL sequences work? Well, first it breaks down PETase, which is polyethylene terephthalate, and PETase is an enzyme that breaks down PET. Then it breaks it down further using MHETase. Next, it breaks down the PET into terephthalic acid and ethylene glycol, both of which are harmless byproducts. Finally, the bacteria eats the terephthalic acid and ethylene glycol. So what's unique about this experiment? So given that this bacteria was only recently discovered, there isn't a ton of research about it, and we'd be the first ones to send it up into space, and that is really important. It's going to help us learn quite a bit about it. So for the experiment design, in the first volume, we put in the bacteria, and then we clipped it, and then we flipped it over, and then in the middle, we have the plastic and the growth medium. And then we clipped that as well, and in the third volume, we put on the glutaraldehyde, which is a fixative. So when the astronauts work on the FMEE, they're going to remove clamp A so that the bacteria can interact with the plastic and the growth medium. And then finally, after a few days, when it's ready to go back into, come back to Earth, they're going to unclamp clamp B, which is the fixative, so it'll stop growing. So it's not going to be growing while it's on its way to Earth, or like metabolizing it. So what are the implications of this experiment? So when I was thinking about an idea for this experiment, I wanted to begin with addressing a problem. And a big problem that we have is obviously plastic pollution. As you can see here, there are about 8 million tons of plastic are thrown into the ocean each year. And then this will allow us to address this problem as well. And then I'd just like to acknowledge Ector County ISD Innovation Department, the Education Foundation of Odessa, Texas Space Grant Consortium, University of Texas of the Permian Basin, University of California, Davis, Dr. David Coyle in particular. And I'd also like to give special thanks to the SSEP, Chevron, and Dr. Jeff Goldstein. I'd also like to thank Ms. Lindsay Lumpkin, my principal, and Ms. Gray, our teacher facilitator, as well as Jason Osborne. They've been an immense help in, getting us to where we are today. Thank you. I didn't want to answer any questions. Sorry. I'm just kidding. Questions?
she has no time.
Hi, my name is Griffith, and I'm from Stamford, Connecticut. So in your research of this bacteria, has there been shown to be any harmful effects of the bacteria in humans or anything else that could impact its usability in the future?
No, not at all. All of the byproducts that the bacteria produces are completely harmless.
Okay, thank you.
Yes.
Hi, I'm Leslie from Nanaimo, BC, and I'm wondering what you're going to do with the information that you gain by sending the bacteria up into microgravity.
Well, what we're looking into doing is to see maybe we can genetically modify it so it'll be more efficient. Maybe break it down at bigger rates. So yeah.
Okay, thank you.
Mm-hmm.
Julia Castillo, New Mexico. So I was wondering, with the implications, it's a bacteria that feeds on that type of plastic.
Yes.
So did you imagine like maybe we could use that bacteria in like treatment facilities, like specialized facilities with that bacteria, or like do you suggest that we introduce that bacteria to like polluted bodies of like natural water?
I think it could go both ways. We could maybe like collect the plastic, or maybe even see how well it works in the ocean. So maybe it can do, metabolize it, or we can put it in like trash facilities where we collect the plastic and introduce the bacteria there.
Okay, thank you.
Ethan Moore, Burleson, Texas. So I was wondering, where did the scientists originally find the bacteria?
Oh, I'm sorry, I didn't mention that. It's in Japan. And as of now, it only exists in Japan,
Okay.
naturally.
Cool, thanks.
One more, sorry.
Sorry, she didn't want to answer my question.
I was ready to go.
So, I know all of this is kind of a new discovery. One of the things that I remember from the beginning of this yesterday was they were talking about commercial space flight. Has anybody approached you and asked about how you could use this bacteria to dispose of like food containers or medical waste that could be used on commercial space flight?
Oh, definitely. That's a great question. That's also another big implication of it and another application of it. So when we go in like long journeys, it gives us something to do with the plastic instead of, just creating more pollution everywhere we go. So we definitely want to use this research to help with that.
All right.
Is that it?
Thank you.
Thank you.
Thank you.